Hi everybody, this is Mr. Nardelli, your statistics teacher for this semester. I just wanted to go over some of the things in Module 1 to help you out. Okay, first off, statistics. It's a branch of applied mathematics that involves a collection of description of analysis and inference of conclusions from quantitative data. That might not mean a lot, but we're going to go through a lot of things here to help you out with some of those words. So there's basically two types of statistics, descriptive and inferential. Descriptive has the word describe in it. They're organized, summarize, simplify, and presentation of data. That could be something as simple as taking a survey of how many different types of pizza people like and creating those numbers in the chart and describing those numbers. Inferential deals with inferences. An inference is a logical guess based on data. So they can generalize from samples to populations, hypothesis testing, and relationships, making predictions. You could see a chart that shows the sales of Coca-Cola have dropped, and you can infer that maybe they dropped due to price increase or summertime or wintertime or whatever the case may be. Okay, when gathering or producing data, there's some things you need to consider. First off, the population. The population is the large group that's being studied. We might study a population of 10 people in our statistics group, or we might study a population of 4 million people in the United States. I don't know if that's the actual population, I just made that up. Now a sample is a subgroup. A lot of times we cannot survey or get information from the entire population. Like the United States, it might be just too big. So a sample is generally 10% or more of that actual population. And members of the sample are called individuals. Any characteristic of the individual is called a variable. So we might be surveying people on favorite color, height, age, favorite type of candy, whatever the case may be. That is the variable. Two different types of data you'll need to know, quantitative and qualitative. A good way to remember that, quant almost has the word count in it. Not really, but I'm stretching there a little bit. So quantitative data has to do with numbers. So if you collect data and a statement might say there are 13 people in class, that's quantitative data. Qualitative, kind of even more, has the word quality in it. It describes using the senses, so non-numerical. You might have data that says all green M&Ms, or hearing or seeing or smelling or such the case. So if it doesn't have numbers, it's qualitative. Okay, now we can break those down a little bit more. The qualitative up on the top in the blue, there's two types of qualitative, nominative, nominal and ordinal. Nominal is unordered. So the order of it does not matter. For example, I might have a list of names of people. It doesn't really matter what order they're in. I could put them alphabetical, but if they're not, my data will still be okay. Ordinal tends to be in order. So it might be something like the months of the year, 1, 2, 3, 4, and 5, and so on. Jumping down to numerical or quantitative, there's what's called discrete. Whole numerical value typically counts like the number of visits to a dentist or something like that. Continuous can take any value in any range, height, pocket depth, or so on. Okay, some of the different sampling methods which I'm going to go over. This just shows the ones that I'm going to talk about. So you can take a look at that, but I'm going to go over each of those individually. Simple random sampling. It's when each member of the subset has an equal probability of being chosen. This is obviously simple, and it's random. So I might be giving people numbers as they come into the classroom. Let's just say there's 10 in the classroom, and I give each number to each person, 1 through 10. I put those numbers in a hat, and I just blindly draw. Number 7, you're the winner. So that is a simple random drawing. It's fair, it's easy, it tends to reduce biases, and it's flexible. Now, the cons are it's hard to list everyone. If I have a group of 10, awesome. If I have a group of 10,000, a little tougher. I usually need larger samples, and I can have sampling errors. You might see on Saturday night, I know Channel 6 has it, the lottery. Those balls come out randomly. It's a simple random thing. Number generators or things like that. Second one is convenience. It involves selecting participations based on accessibility. So the example I have here, a researcher conducting a study of cancer survivors' experiences may choose to recruit volunteers using social media. So he might put out there, hey, anybody want to do this survey? The advantages, it's easy to collect. It tends to be inexpensive, and there's fewer rules and it's low cost. The disadvantages, it can have bias, and it tends to be unclear. I'm sorry, that's spelled weird. I think that's British. Generalizability and high level of sampling error. So if I put a survey out there, or just say, hey, cancer survivors, you want to do a survey? I could get different biases involved in there. Systematic. It's probability sampling method where researchers select members of a population at regular interval. So I might have a conference where I am talking about something, and I'm expecting like 150 people to come in. So I might select every 15th person. It's completely random, and it's kind of fair. It's more time efficient. Now the disadvantages, every member must be listed, so I need to wait for every single person to get there. The first member of the population must be chosen at random to avoid biases. So I can't sit there and go, okay, the third person is my friend Jimmy. I'm going to start with number 3. That could be bias. And if it's missing, the entry is not included. So you can see it's kind of good to do. You see advantages and disadvantages of a lot of these. Cluster. You divide a population into clusters such as districts or schools. So the advantage, it's less expensive and it's less time consuming. The disadvantages, error, it does exist and it might be less accurate. Now this might be, for example, I would take, like it says, districts or schools. I might select just a certain school in Melbourne. Let's just say I picked Arizona College of Nursing. Boy, is it simple. I can just survey you all. Now, error can exist because there's a different type of population in Arizona School of Nursing compared to a technical school that works on fixing cars. That's a different type of population. Stratified, they divide the subgroups into, the subjects into subgroups, maybe race or gender. So I might say, if I have a larger group, I will divide them into male and female, and then I might randomly pick 5 people from each group. It's good because I will get 5 male and 5 female, which kind of mixes things up a little bit. The disadvantage, it requires information on the population, and calculation errors can happen. So it is a little bit tougher. Okay, now you'll see this. I want you to text this movie star's name to me at 410-929-1431. If you text it to me, then I will know you watched this video. Thank you. Can't wait for the class. Bye-bye.